Listen in as Air Traffic Controller Kevin Coyne shares his insights on using Sector 33 and the Smart Skies ATC game with students. Hello, this is Bonnie Murray, your education specialist, and I'm here with Kevin Coyne. Hello, Kevin.
Hi.
Kevin is an air traffic controller working out of Richmond International Airport in Richmond, Virginia. This is what the Smart Skies program looks like. It's in some ways similar to air traffic control and in some ways different. So let's talk about first how it's similar to air traffic control.
Well, this is the Sector 33 Smart Skies app. It uses distance, rate, and time math problems to separate aircraft and get them to their destination airport over a certain fix in a certain amount of time and in the safest, most efficient way possible.
Mm-hmm. So the aircraft are moving through the sky, and just like in real air traffic control, there's some calculation involved. The math is a part of air traffic control. And so this game that is available as the app, or the program you can use on the computer, allows you to practice that math as you would as if you were controlling and doing air traffic control.
Yes.
Similar to that way. Okay. Now the one thing it does not do, the way it's different, is it does not allow you to control altitude. Right?
No.
All of the planes are at the same altitude. So how is altitude decided in real actual air traffic control?
Well, in the game, aircraft are all treated as the same type of aircraft.
Mm-hmm.
They can only go certain speeds, and they're all at the same altitude.
Mm-hmm.
It makes the math equations a little bit easier.
Mm-hmm.
The difference with real air traffic is in real air traffic, aircraft are at different altitudes. There are different types of aircraft flying in the system, and they all have different characteristics. You have small little single-engine Cessnas. You have large jumbo jets, larger planes, medium-sized, mid-range planes, and every one goes a different distance, has different capabilities, different air speeds. They all perform differently, and that makes the system a little bit more complex and provides different things for different aircraft to do in the system.
Right. Okay. So if you think about the atmosphere, then I'm thinking of how as you travel up through the atmosphere, there are physically less particles of air as you travel further up. So
yes.
One of the capabilities that would be different is the planes that are capable of traveling at higher altitudes would need a pressurized cabin and things like that. So smaller aircraft like the Cessna that don't have that are limited to the altitude they can fly. Is that correct?
Yes.
Yeah, very interesting. And then based on the altitude that they can travel, that also dictates the speed that they can travel at as well, right?
Yes, and you don't want small planes mixed in with large planes, so a small plane in front of a larger plane, so they have different routes to be on and everything, and with their different capabilities, you have them at different altitudes also.
Okay, all right. So let's look a little bit more closely at this app. Let's really zoom in and show you what's available and what the app looks like when you go to your computer or your iPad. What would the app actually look like?
All right.
Let's go to that.
So this is the Smart Skies app on the iPad. As you see, it says Sector 33. In the top left-hand corner it has the NASA logo, and you just click on that, and it brings up the Sector 33 air traffic control math problem. Now what we're going to start with is we'll go to the help screen. On the bottom there are 4 tabs. The third one is help. We'll click on that, and we'll go to the introduction, which is the top screen. This is the Sector 33 app. It shows you 2 aircraft. If you look straight across all the way to the right-hand side, about the middle, you'll see a green circle with a diamond in the center. The diamond represents the aircraft. As you see on the bottom, it says Delta, DAL 88, and has a circle around it. On the top, you have American 12, which is AAL 12, and it's blue. The center of the circle is the diamond, is the aircraft, with a 1-mile circle around it.
Okay, so just to recap, what you're seeing there is the tabs are telling you the name of the airline, and the circle is showing you the plane and the safe zone around it.
Yes.
Yes, okay.
What we're trying to do is trying to get these 2 aircraft to travel over Modesto Fix, which is the MOD Fix, into San Francisco Airport. And if you hit the next arrow on the bottom, go over. This is the radar screen that we're going to be looking at. And as you saw on the last question, the highways in the sky, this is our jet routes. The white lines are the jet routes that the aircraft is on. Each one of these little hash marks, the tick marks, is 1 nautical mile. And we're using nautical miles because the aircraft are traveling in knots. It's a different unit of measurement than most people are used to. In cars, we use miles per hour.
When we're on the ground, right?
When we're on the ground. We use knots and nautical miles in shipping and in aviation because of the curvature of the Earth. So each one of these little hash marks represents 1 mile. So as you see, from Modesto, Delta is 33 miles. So you have 1, 2, 3, 4, 5. Then it goes 5, 10, 15, 20, 25, 30, and then you count 1, 2, 3. So you have 33 miles away. You go to the next screen. As the Sector 33 air traffic controller, our job is to get the 2 aircraft, American that was on top and Delta in the center, over Modesto into San Francisco, 3 miles apart. So as you see, Delta's at 0, and American is, now between the edges of the circle, is 1 mile. And we have a time limit. If you look at the top of the screen, it says 3:18 on the left, and then it has a green bar, and then 3:18 on the right. You have 3 minutes and 18 seconds to get both aircraft over Modesto into San Francisco in 3 miles. 3 miles apart.
Right. So the ideal spacing at the end needs to be that 3 miles apart. Got it.
Yes. You see they're both traveling at 600 knots. And now we go with the next screen. If you do that at 0 and then 3 miles away, you'll have a perfect score of 200 out of 200. Now, 2 ways to accomplish your goal of getting the aircraft 3 miles apart past Modesto are by changing the speed and the aircraft's route.
Okay, so there are 2 choices you have.
There are 2 choices you have.
You can adjust the speed or you can adjust the route, okay?
Now, Delta is going to go straight ahead because that's the only way for him to go. Most aircraft are not going to go backwards and then zigzag around to come to their airport. We want to get aircraft as safely and as efficiently, and the most efficient way would be to go straight. But if you look on top, you have American, and you have 2 options for American to go. He can go to Mina intersection and then to Modesto, MOD, or he can go to Mina and then OAL to MOD. So he has 2 options. And the way to change this is you can click on the data tag, which the data tag is where it says American 12 and has the speed of 600 knots. And down, you will be able to pick different speeds that he can go. And the speeds are in increments of 60 knots. Okay. So you have the choice of 600, then 540, then 480, 420, all the way down to 300.
All right, and we'll see that in a future screen where we can actually pull that down out of the menu, right?
Yes.
So what would be some of the reasons that a flight would be changed from its pathway? Why would you choose the alternate route?
Sometimes the alternate route would be chosen. There might be a weather phenomenon between Mina and OAL that he can't go that way, so he has to go down from Mina to MOD.
Or vice versa.
Or
he might want to divert. Okay.
If there's weather over here, he might need to divert that way and get into there.
Okay.
If he needs to maybe be behind Delta for spacing, to ensure adequate spacing, it would provide extra spacing behind him.
All right.
And we go to the next screen.
There we go.
And you see that you can, once you touch the data tag, it will give you an options. It will show you the route that he's on. He's going to Mina, the dark line, to OAL, to MOD. If you take your finger on that white circle and drag it up to the other way, Mina to MOD, he will now go that way.
So you can accomplish a route change that way.
You can accomplish a route change that way. Now you also see on the right-hand side you have a column that changes the airspeed. And you see you can change the airspeed in increments of 60.
Okay.
The data tags in the speed menu can be moved out of the way if you need to. You can touch the data tag and you can drag it to any point on the screen and then just let go, and that will be where the data tag will be left. So if they're getting too close and you can't tell what's going to happen right here, you can move the data tag away from it. If you get the planes too close together, as you see here, not what we had over on the left-hand side past Modesto, you see that the two circles are touching, which means that between the center and the edge of the circle is a mile, and the edge of the circle on American and the blue circle is a mile. So right now, between the center of the planes is only 2 miles, and they're getting closer to each other. So if the planes are too close, you get a 0 score, and that's what we're trying to avoid. That's what we don't want to happen. So that's a brief overview of how to play the app and separate air traffic using distance, rate, time problems.
Great. So the beauty of this is you're finally going to see why you need to know that math. You're going to see a real-life example of where that math comes into play. So that's a wonderful thing. Good. So let's go back to the main screen and get an idea of how this actually works. Kevin, can you show us that?
Yeah, what we're going to do now is run through a problem. We're on the main screen now. We're going to go to Levels, which is the second tab. And as you see, there are 4 different levels to do. There's Trainee with 8 problems. Then you can go to Basic. It has even more problems with 10. And as you increase, Trainee you'll start with 2 planes. Basic will move up to 3 planes. Expert you'll have 4 planes. And then Master you'll have 5 planes.
5 planes to juggle moving down those runways.
5 planes to juggle. We're going to start with Trainee. We're going to do the first problem, which is 2-1. And you see on the screen we have Delta Flight 88 and United Flight 74. Now, if you look at the hash marks, as I talked about before, we're 35 miles away with Delta from MOD. And with United 74, if he goes LIDAT intersection to MOD, he's 35 miles away. Now, if he goes LIDAT to OAL to MOD, you got 13 miles here to OAL, then 10, which is 23, and then you have 15. So he's actually 38 miles away. Now we don't know which way he's going until we start the problem. On the top, you have the home button. To the right, you have the play button, which will start the clock. And right now what we're going to do is we're going to hit start.
And get the action going. There we go. All right.
So
now they're moving very slowly.
They're moving very slow in real time. You can increase this right now. Right next to the play button is 1 time. You can go 4 times or 10 times as fast. If you click on that, on the center of the plane, you'll see the speeds and the direction that he's flying. So right now we know which way Delta's going, and we know which way United's going. So we need to do something because they were both 35 miles away, and they're both at 30 miles right now. So I'm going to look at United, check the speeds, see what speed he's going, and figure out what I need to do. So I look at all the different speeds, and I say, what's the best speed that's going to help me separate him from Delta, making him number 2? And I'll put him at 540. Now, as an air traffic controller, if I know that I've separated these aircraft in enough time, then I can focus my attention on other potential conflicts or other things that are happening in the airport environment.
Right, because at this point you've separated them by slowing that one down so that by the time they get to the intersection over there, they will be the safe distance apart.
Yes, and if you're sure enough that you did it, you can hit 4 times to speed the problem up, or you can go 10 times. And then you can watch, and if you've done the math correctly, you know that the aircraft will be perfectly separated and they're never going to touch. And remember, our goal is 3 miles of separation. So if he's at 0 right now, and you look at Delta, he's at 3. So you have the 2 aircraft separated by 3 miles. On the top right, it says your score 200 out of 200. Congratulations, you are now a junior controller. You've separated the aircraft using math in the time allotted, and you've hit a perfect score.
And you've got your perfect score, so success. Perfect score. That was a really good job there. Great. I hope that you students will enjoy playing with this game, experimenting with the different math calculations, and work your way all the way up to expert and earn your perfect scores as you go along. Thank you, Kevin. That was a great explanation.
Thank you.